Bismillahirrahmanirrahim. Exercise 9.5. Question number 17. 3x square y plus 2xy plus y cube into dx plus x square plus y square into dy is equal to 0. स्टैंडर्ड फॉर्म से कंपेयर किया की वैल्यू हमारे पास ये आ गई जो dx के साथ है, n की वैल्यू जो dy के साथ है वो वाली होती, m को पार्शियली डिफरेंशिएट किया विद रिस्पेक्ट टू y, n को पार्शियली डिफरेंशिएट किया विद रिस्पेक्ट टू x, दोनों कॉन्सेप्ट डिफरेंट और इक्वेशन नॉन एग्जैक्ट है. So we will try to find the integrating factor. For this we will get the value of my minus nx divided by n. After putting the values of my minus nx divided by n, we get 3, and 3 is a function of x, because we can write 3 as 3 into x raised to power 0. So we will find the integrating factor, which is e raised to power integral of 3 dx. Its mean it is equal to e raised to power 3x. Multiplying equation static by the integrating factor, and this equation will become an exact equation. Multiplying equation static by integrating factor, we will get e raised to power 3x into 3x square y plus 2xy plus y cube into dx plus e raised to power 3x into x square plus y square into dy is equal to 0. We name this equation as static prime. Its mean or new m is e raised to power 3x into 3x square plus 2x plus y cube, and new n is e raised to power 3x into x square plus y square. We will repeat the process. We will find curly m by curly y and curly n by curly x. Here curly m by curly y and curly n by curly x have the same results, which is e raised to power 3x into 3x square plus 2x plus 3y square. So the equation is exact. Now we will integrate m with respect to x and integrate the terms of n which are free from x. Here there is no term in n which is free from x, so we will integrate only m. This will generate the general solution. We are integrating them. You can check the process. Simply we apply integration by parts. As you can see that first, as it is integral of second minus whole integral of second into derivative of first. Similarly in this integral, first as it is integral of second, which is e raised to power 3x by 3 minus whole integral of second into derivative of first, and the derivative of x is 1. Here integral of e raised to power 3x is e raised to power 3x divided by 3. We will just simplify this equation and get the general solution. It is the simplification 3y into x square e raised to power 3x divided by 3 minus 2 by 3 into x e raised to power 3x divided by 3 minus e raised to power 3x divided by 9 plus 2xy e raised to power 3x divided by 3 minus 2y e raised to power 3x divided by 9 plus y cube e raised to power 3x divided by 3 plus c, constant of integration. These terms will cancel each other, and we will get only x square y e raised to power 3x plus y cube e raised to power 3x divided by 3 is equal to c1, which is our general solution. Multiplying the equation by 3, and 3c1 is also a constant, because product of two constants will give us a constant. So our general solution is y raised to power 3x into 3x square plus y square is equal to c. Exercise 9.5. Question number 18. Y dx plus 2xy minus e raised to power minus 2y dy. Differentiate m partially with respect to y. Differentiate n partially with respect to x. These results are not same, so equation is non-exact. We will try to find the integrating factor my minus nx divided by n. After putting the values, we get this result, which is 1 minus 2y whole divided by 2xy minus e raised to power minus 2y. As you can see, it is not a function of x only, because y appears here. So we will find nx minus my divided by m. After putting the values, we get the result 2 minus 1 over y. No x appears, so it is only a function of y. So we will find the integrating factor. Integrating factor is equal to e raised to power integral of 2 minus 1 over y into dy, which is equal to e raised to power 2y minus the natural log of y. We will use the rule base same powers add, so we will get e raised to power 2y into e raised to power minus natural log of y. Here minus 1 will become the power of y. Natural log and d will cancel each other and we will get e raised to power 2y divided by y, which is our integrating factor. We will multiply our given equation, I mean steric, by the integrating factor. After multiplying by e raised to power 2y divided by y, we will get e raised to power 2y into dx plus 2x e raised to power 2y minus 1 over y dy is equal to 0. This is our new m, this is our new n. We will repeat the process and find curly m by curly y and curly n by curly x. Curly m by curly y is equal to curly n by curly x is equal to 2 e raised to power 2y. So the equation is exact, and we will apply the method which is used to solve the exact equation. We will integrate m and integrate those terms of n which are free from x. This is the only term, minus 1 over y, in the n which is free from x. So we will integrate e raised to power 2y and minus 1 over y. E raised to power 2y is constant and integral of dx is x. Integral of 1 over y is natural log of y. So we will get the general solution, which is x e raised to power 2y minus natural log of y is equal to c. Exercise 9.5, question number 19. E raised to power x dx plus e raised to power x cotangent y plus 2y cosecant y dy is equal to 0. Here m is e raised to power x, n is e raised to power x cotangent y plus 2y cosecant y. We will differentiate m partially with respect to y. Through this we will get 0, and we will differentiate n with respect to x partially. Through this we will get e raised to power x cotangent y. Because curly m by curly y is not equal to curly n by curly x, so equation is non-exact. So we will try to find the integrating factor. For this we will check what is the value of my minus nx whole divided by n. After putting the values of my, nx and n, we get this result, which is not a function of x only because y appears here. So we will find nx minus my divided by m. After putting the values of nx, my and m, we will get cotangent y, which is a function of y only because here there is no x. So we will try to find the integrating factor. Integrating factor is equal to e raised to power integral of cotangent y. Cotangent y can be written as cos y over sin y. Cos y is the derivative of sin y, so we will get e raised to power natural log of sin y. E and natural log will cancel each other and our integrating factor is sin y. We will multiply the integrating factor with the equation steric, and that equation will become an exact equation. Multiplying equation steric by integrating factor, we will get this. This is m e raised to power x sin y. We will find curly m by curly y, which is e raised to power x cos y, and n is e raised to power x cos y plus 2y. After differentiating n partially with respect to x, we get e raised to power x cos y. So curly m by curly y is equal to curly n by curly x. Equation is exact, so we will apply the method of exact equation to find the general solution. We will integrate m and the terms of n which are free from x. Here 2y is the term which is free from x. So we will integrate sin y e raised to power x and 2y. After integrating, we will get the general solution, which is e raised to power x sin y plus y square is equal to c. Exercise 9.5, question number 20, last question of exercise 9.5. X plus 2 into sin y dx plus x cos y dy is equal to 0. After comparing with the standard form, we will get m, which is x plus 2 into sin y, and n, which is x cos y. Differentiating partially with respect to y and differentiating partially with respect to x, we will get curly m by curly y and curly n by curly x. These are not same, so equation is non-exact. So we will try to find the integrating factor from my minus nx divided by n. After putting the values of my, nx and n, we get this result, cos y into x plus 2 minus 1 over x cos y. After some simplification, we will get x plus 1 over x or 1 plus 1 over x, which is a function of x only. So we will find the integrating factor, which is e raised to power integral of these two terms. Through this we get x e raised to power x. Now we will multiply the equation steric by the integrating factor. After multiplying the equation steric by integrating factor, we will get e raised to power x cos square sin y plus 2x e raised to power x sin y into dx plus x square e raised to power x cos y dy. This is our new m and this is our new n. Now we will find curly m by curly y and curly n by curly x. Curly m by curly y is equal to curly n by curly x. So equation is exact and we will apply the method which is used to solve the exact differential equations. It's mean we will integrate m and integrate those terms of n which are free from x. Here there is no term in n which is free from x, so we will integrate only m. After integrating we get x square e raised to power x sin y. So general solution will be x square into e raised to power x into sin y is equal to 0. Now we will solve equation. Now we will check exercise 9.6 which is related to linear equation and Bernoulli's equation.